Hi, in addition to additive representations, there's also multiplicative representations. The K is actually the number, okay? And then X, of course, is the variable. So here's the situation. Miss Morgan goes to Starbucks every day and spends $5.25 on a venti mocha coffee drink. Represent the total amount of money Miss Morgan spends for a different number of days. So verbally, Mrs. Morgan spends way too much on coffee. Just kidding. Miss Morgan spends $5.25 a day. Every day. Mr. Morgan would hate that if this were true. Okay? So here's a visual. There's my coffee, $5.25. Let's say this is Monday. This is Tuesday. This is Wednesday. This is Thursday. You guys get the idea? And then it keeps going on forever and ever and ever until she has no more money. Just kidding. Okay, so what would the equation look like? Okay, the amount of money I would spend, this is the money, total money that I would spend, would equal $5.25 times the number of days. So this X represents the days that I go. So if I go 1 day, it's $5.25. If I go 2 days, that's 2 times $5.25, which is $10.50. If I go 10 days, it's $52.50. Okay, so the Y is the total amount of money. The X is the amount of days we go. So what do we do with this information? Well, we make a data table. Okay, so remember what we said the X was? X is the number of days. Y is the total amount of money. Okay, so X is the number of days, and Y is the total amount of money. Okay, so if I go 1 day, it costs $5.25. If I go 2 days, that's double, $10.50. If I go 3 days, I'm not doubling it again, right? I'm just spending another $5.25, so that's $15.75. If I go 4 days, I can add another $5.25, or I could double the number 2, which is easier for me. Day 5, I'm going to add another $5.25, so that would be $26.25. Okay, I could keep going and going and going and going. Now, if I'm going to graph it, here's my Starbucks order. Down here is the number of days, because remember we said that the X was the number of days, and over here, this would be the total money, right? That's your Y. So X goes side to side, Y goes up and down. All right, we have no money here. I'm going to make it easy, and I'm going to say each one of these is a quarter. So here's $1. 1, 2, 3, 4. Here's $2. Whoops, I probably better do not that much. Let's do $1 on this one. $2 here. $3 here. We're going to run out of room. $4. $5, $6, 7, 8, 9, 10, 11. Okay, so there's all my dollars going up. So on 0 days, I spent $0. Mr. Morgan is a happy, happy man. If I go 1 day, I spend $5.25. So I'm going to go $5.25. It's going to land about there. Okay, if I go 2 days, it's $10.50. I'm getting this money from right here. So 2 days is $10.50. Okay, 3 days, I'm off the charts. So when I create my line, I have to say, sorry, if it's solid line, I would be able to go half a day and half a drink. I can't pay for half a drink. So it has to be a dotted line because I cannot do halvesies. right? So a dotted line looks like little dashes going down. And all that's doing is that is showing me that there is a linear relationship. It does go through 0, 0 because 0 drinks, $0. What else do we know about it? Because it goes through 0, 0 and it's linear, it's called proportionate. And what else do we know? It's multiplicative. It's multiplicative because I'm multiplying everything on the X column. I'm multiplying it by 525 every day I go, right? So 1 times 525, 2 times 525. So it's a multiplicative relationship. When you have a linear graph and it goes through 0, 0, it's always going to be multiplicative. You don't even have to do any math to know that it's multiplicative. If it's a line and it passes through 0, 0, you can automatically know it's multiplicative. If you have any questions, ask your teacher.